Hello everyone, my name is Payne, like paying the bills, and the theme of today is environmental enrichment, or environments with sensory stimulation. Now you might be thinking, you're in a room with all white walls and no windows. What do you know about environmental enrichment? Well, my friends, about as much as scientists knew before the publication of Rosenweig-Bennett and Diamond 72, which basically showed that our brains, or rodents' brains, might change in response to our environment. So how exactly would a study like this one be designed? Well, basically, there were 3 male lab rats, each of which would be assigned to either an impoverished, enriched, or standard laboratory condition. In the enriched condition, rats were grouped together with novel objects that were exchanged every day. On the other hand, for the standard environment, the rats were in groups, but at the same time, they weren't given all of these novel stimuli. For the impoverished environment, they were neither in a group nor given all of this stimulating environmental stimuli. The publication itself is more of a combination of studies conducted throughout the 50s and 60s, with the 1964 version suggesting that rats in enriched environments between 4 and 10 weeks had thicker cerebral cortices and heavier cerebral cortices by the end, along with higher activity of enzymes like cholinesterase found in cells that supply nutrients to the neurons. Many mini replicates were done of this study, mostly because of the dogma of the period that the brain does not change in response to experience, with this paper being one of the seminal challenges to this misconception, one of the first since the start of the 20th century. While the study was conducted using only male lab rats, the replicates and the variations of the experiment are very, very comprehensive and account for many different confounding variables. While one of the primary points raised by the study was the importance of not immediately trying to generalize these findings to humans, there have been many human studies that have shown that enriched environments likewise contribute to neuroplasticity. One of these studies, performed by Ying et al. 2022, addresses many of the important points that were raised by Rosenweig's team, including the relationship of enrichment to memory, the difference between real-world and laboratory enrichment, as well as I mentioned before, the generalization of these findings to humans. So basically, 99 male and female participants between the ages of 55 and 85 with mild cognitive impairment were assigned to one of 3 different groups: the virtual reality cognitive therapy group, the control group, or the exercise group. The virtual reality cognitive therapy group underwent 24 sessions, 24 100-minute sessions, of 3 times per week of 4 different virtual reality games focusing on executive function and attention, while the exercise group underwent 24 sessions of moderate intensity aerobic exercise and resistance training. The control group, on the other hand, enrolled in a nutrition course on dieting and exercise for preventing geriatric diseases. The attention was measured using dry electroencephalogram, and the cognitive function was assessed using the mini mental state examination, the trail-making test, as well as the symbol-digit substitution test. With respect to the results, Yang and colleagues found that VRCT improved cognitive function more than exercise. However, exercise improved physical functioning more than VRCT. Overall, though, both VRCT and exercise improved global cognitive function, as well as gait speed and hand grip strength. While the study had many high points, including incorporating both males and females, as well as having a decent sample size, it still had its fair share of limitations. For example, the frequency between the VRCT and exercise conditions differed. The exercise groups actually performed exercise twice per week for 12 weeks, while the VRCT group met 3 times per week for 8 weeks. Still 24 sessions, but still differences in terms of their frequency. Additionally, females outnumbered males pretty significantly in each condition. Future studies might look to address this imbalance or to address the frequency differences between the VRCT and exercise conditions, especially considering that there were pretty significant differences in terms of the neuroplastic changes that were observed between them. In spite of its restrictions, this study still has far-reaching implications. For example, for the at least 700,000 people with dementia in United States nursing homes, many of which exhibit low levels of cognitive, physical, and social activity, combined virtual reality and exercise programs could be implemented. Taking advantage of virtual reality's haptic feedback, realistic graphics, and portability, these rehabilitation centers could be transformed into hubs of movement, interaction, and mental stimulation.